Today we're going to talk about the kinetic theory of matter using this simulator here. If you look up PhET online and type in states of matter simulator and hit run now, this is a great simulator to help us today. So after you've tried out the simulator, I'd like you to try to answer these two questions. Explain how hot and cold temperatures affect different atoms, and are the results for each substance, which you'll see on the simulator here, the same or are they different? So let's jump into the simulator. Now hopefully you've already taken a look at this and just seen some of the basics of how it works. Over on this side you can select from different atoms and molecules. Let's pick water because it's something we're familiar with. And you can change the state from a solid to a liquid to a gas. And if you did the first lesson, those should start to make sense in the properties of each of those. We're going to start with a solid today when we talk about kinetic theory of matter. The first thing I want you to do is see that there's this simple device here that just helps us heat things up or cool things down. And while you're using this, I want you to also pay attention to the thermometer up here. And notice this value is in Kelvin, which is something we don't often use in class, but the idea is that it measures temperature, and you can just see there's still a normal temperature change you would expect. So right here we have let's look over here quickly, we have a water molecule. Remember, a molecule is something that is made up of more than two atoms, right? So this is a hydrogen atom, this is an oxygen atom. In the oxygen we have two oxygen atoms, which makes this also a molecule, and argon and neon are both single atoms if we use one of those. So what is kinetic theory of matter? Well, if we apply heat to this situation, we can see that the particles start to move faster and faster. Basically what's happening is the particles are gaining energy. So each of these molecules gains energy, they gain kinetic energy, and they go faster. That's simply it. That's the kinetic theory of energy, or the kinetic theory of matter, that when the particles gain energy, they move faster. If we cool this system down, now what's happening here, it's not that the particles are moving slower because of the ice, it's because when the particles hypothetically bump into something cold, they lose energy. And when they lose energy, they start to move slower and slower and slower. And as you can see, one of the features, when particles lose energy, they'll clump together, they'll turn back into a solid state from what is some higher form, either a liquid or possibly a gas. Okay, so let's take a look again quickly at our two questions here about the temperature. So down here I've got a real basic couple of screen captures of some of these. And again, if we're looking at the kinetic theory of matter, we can see that in this picture here, we have a low energy, and they are slow moving. Remember, these particles would vibrate in place. And the simple continuum is that if you add energy to this, we have a higher energy, and these particles would be moving very fast. That's simply the kinetic theory of matter, that if things are cold or the particles have less energy, they're usually clumped together, they're moving slowly, and if the particles are, if there's a lot of energy, the particles are going to move much faster. Okay? And then getting back to our other question, are the results for each substance the same or different? Well, if we go back and we look at this, we can see some quick comparisons that in this case for neon, there's a solid state at about 5 degrees Kelvin, and the gaseous state here happened around 62 degrees Kelvin. If we go back and compare that to our water, the solid state, we can get to as warm as 157 degrees Kelvin, and the gaseous state is at 809 degrees Kelvin. And because they're different elements, they're going to have different properties. One of those properties being how they respond to hot and cold temperatures, or to the gain or the loss of energy. Okay, so I hope you get a chance to work with the simulator a little bit more today and understand the kinetic theory of matter based on how particles gain or lose energy. Thanks for tuning in today.